Hello, I am Man Chow, Kenneth Chow. This is my quantum gravity video number 36. Today's topic is there are two. A, why is gravity always attractive? Never, that is to say, gravity is never repulsive. Why? And the second topic is B, the enlightenment. About the gravity, the mysterious gravity. First, why is gravity always attractive? A most enlightening, most illuminating explanation is to be found in Volume 1, the Feynman's lectures on physics. I always like to quote Feynman's lecture because it's both the ground cover is both broad and very detailed, most detailed by Professor Feynman. It's on page 12.6, section 12-3, and the topic was called molecular force. I will briefly quote from that section. First, I call this a quote A. I now begin to quote. Empirically, the force between two atoms is illustrated schematically in figure 12-2. The figure is the figure. This figure 12-2, and it was called the force between two atoms as a function of the distance of separation. This was not drawn to scale, of course. And then I've modified from the figures 12-2. I modified it by adding. Originally, it's only up to this R here, but I extend it to infinity. That is to say, the distance between these two atoms, 0 here is one atom, this another atom here, or this movable. The distance can be variable, but then the distance is called d between two atoms, called d. I extend it to infinity. I continue to quote. There are different cases. In a water molecule, for example, the mean positions of the negative charges and of the positive charges are not at the same point. Consequently, another molecule nearby feels a relatively large force, which is called a dipole force. Dipole-dipole force. For oxygen gas, which is perfectly symmetrical, the distribution is such that the center of the minus charges and the center of the plus charges coincide. A molecule where the centers do not coincide is called a polar molecule, and the charge times the separation between the centers is called a dipole moment. A non-polar molecule is one in which the centers of the charges coincide. For all non-polar molecules in which all the electrical forces are neutralized, remember, non-polar molecules, the electrical forces are all neutralized. It nevertheless turns out that the force at very large distance is an attraction and varies inversely as the seventh power of the distance, or F stands for force, is equal to K divided by R to the power 7. Where K is a constant that depends on the molecule, because all molecules are different. As just quoted the two cases up there, for water molecule and oxygen molecule, they are different. So the K depends on the molecule concerned. I continue to quote. When they are dipoles, the forces are greater. When atoms or molecules get too close, they repel each other with a very large repulsion. I call this sentence quote B. I continue to quote. I call this quote C. These molecular forces can be demonstrated. The friction experiment with a sliding glass tumbler. Another is to take two very carefully ground and lapped surfaces. Lapped, L-A-P-P, means one on top of the other, which are very accurately flat. An example of such surfaces is the Johansen blocks. If one such block is slid over another very carefully, and the upper one is lifted, the other one will adhere and also be lifted by the molecular forces, exemplifying the direct attraction between the atoms on one block for the atoms on the other block. Now, end of quote. I've finished my quoting. And then referring to the figures. From code A, I just finished quoting. The first part is code A, I call it. We are told that the separation, when the separation between atom A and atom B, say atom A and atom B is added to the figure. Originally, in the Feynman's lecture, there's no put atom A and atom B, but I call this one atom A, atom B, atom B, atom A, atom B. When the separation between atom A and atom B, that's to say D in the diagram, is a very large distance. This is important. That's to say at least macroscopic distance. The force is an attraction of F is equal to K divided by R to the power 7. I've just quoted. the force varies inversely as the 7th power of the distance. And if atom A and atom B are in non-polar molecules, as explained above, non-polar molecules, as I have just read out in the quote A. In neutral objects, in non-polar molecules, they are in all electric forces are neutralized. They are neutral between neutral objects. If atom A and atom B are in polar molecules, as explained above, having dipoles and dipole moments, the force is greater. How much greater? This is my own version. Up to F is equal to K divided by R3. Why you can see this in my video 13 and video 32, a more detailed, elaborate explanation of the dipole force, the dipole moments. From the quote B, we are told that when D becomes very small, the atom A and atom B will repel each other strongly. But this is, of course, this only occurs when D is a subatomic separation distance. Such repulsion will definitely, if it's subatomic distance, will definitely be classified as a strong or weak nuclear interaction. Will not be classified as a gravity. From code C, we are told that very large distance. Code C that means about the friction glass tumbler experiment, or the two glass blocks, one on top of the other, slid over the other, and then lift up the other blocks. That's what glass C is, the code C is about. We are told that very large distance include down to such a separation distance between two flat glass blocks, one on top of the other. The distance is still macroscopic, that is to say it can be seen with naked eyes. The force in such cases is still attractive, because one block slid over the other carefully and lift up the other block. This explains why gravity is thought to be always attractive, never repulsive, because all the way from very large distance down to this distance, macroscopic distance of two glass blocks, one on top of the other, the force is still attractive. But we change another circumstance when two magnets were placed with like poles, north pole to north pole, south pole to south pole, towards each other. This is also not macroscopic. This can also be seen with the naked eyes. But however, this will definitely be classified as an electromagnetic interaction or electromagnetic force, not gravity. Whereas the electromagnetic and the gravitational force, that's to say gravity, have been proved by me to be one and the same force. Why a lot of previous video 5, 13, 14, 15, 19, 20, 22, 30, 32, and 34. These three forces the strong, the electromagnetic, and the gravity all originate from the attractions of my Planck black hole theory, the Planck black holes in my Planck black hole theory, and the repulsion of the Planck white holes. The Planck white black holes is in my hypothetical theory. It is they are the positive charges, whereas the Planck white holes in my theory, they are the negative charges. Now, I finished the topic A. That is why gravity is always thought to be attractive and not repulsive, because down to the least distance thought to be within the ambit of the gravity, that is to say, like two flat blocks, one on top of the other, it is still attractive. The force is still attractive. That's why they call it the gravity, consider gravity as attractive, always attractive, not repulsive. Now I've continue on the B, the second topic. That's to say, the enlightenment. The enlightenment that is about the mysterious gravity. The nature and the origin of gravity has always been intriguing and puzzling, because over the seemingly empty distance of millions and even billions of miles, the sun attracts the planets to revolve in their orbits. Even still more puzzling is the fact that electromagnetically neutral atoms and molecules, they attract equally neutral atoms and our molecules over great distances, up to light years, so that they eventually merge to become nebulas in which the stars will eventually form. Now, from the above quote A, from the quote 8, we are told that at very large distance, this is repeated several times, at very large distances between electromagnetically neutral or non-polar molecules, atoms in this kind of molecules, there is still a force of attraction. The force equal to, this is repeated, K divided by R, the distance to the power 7. And such forces become even greater when they are dipole force. You can have more detailed, elaborate description and explanation of this dipole force in my videos 13, 32, and 34. In the case of polar molecules, it means, just as explained above, polar molecules means they are when they are the centers of the positive charges and negative charges do not coincide. Then they become two centers. Dipoles become two centers, and so they will become a dipole moment. There will be a dipole moment, and the force between them is called the two objects is called dipole force. But even though they are polar molecules, the objects are still as a whole neutral, electromagnetically neutral. Such forces have been always classified as gravity. They are classified in the same category as like a falling apple, an apple falling, or the planetary motions, like the sun, the planets evolving around the sun in the sun's gravity. Because the objects involved they are electromagnetically neutral. They are so always when object is involved are electromagnetically neutral, they always consider the force between them to be gravity. That's why we have the puzzling mystery of gravity. Why gravity is there should not be such gravity between electromagnetically neutral objects and over long distance of up to light years. But there were. That's why it's so intriguing and so puzzling. But actually, if you, as explained by Professor Feynman, there is still a force. The least force is equal to k divided by r to the power 7. The distance to the power 7. And the greater one, the dipole force is up to k divided by r3. If you can read over refresh back my video 13 and video 32, you will know have a that will find and elaborate a more detailed description and of the method of derivation of this r to the power 3. But even r to the power 3 is much bigger than r to the power 7. But there, if you calculate using this r to the power 3, it's still the gravity will be calculated to be 10 to the power minus 39 of the magnitude of the strong force. That's why it's always called gravity is so weak. But actually, as I said here, the strong force, the electromagnetic force, and the gravity are all the same one and the same force. They are not two different forces. What determines the magnitudes are only the distances between them and the magnitude of the charges involved. The charges, of course, directly proportional to the mass. You'll find this is the formula, what I call the quantum form equation. As to say, Planck mass times c squared times an integral multiple of Planck mass divided by Planck length and times integral multiple of Planck length. Then it's the formula for these all three forces. Common because they are common to all three forces. They are quantum. That means because they are in Planck mass and Planck length, the smallest unit of length and mass. Quantity, not the smallest, because the Planck mass is very great in magnitude, but they are the quantum. Nevertheless, Planck mass is a quantum of mass, and Planck length is a quantum of the length. So I finished my 2 topics here, and if you're interested, you can subscribe, and I finish here today. Thank you. Bye bye.